Hey class, and welcome to lesson 4.7a, applications of exponential functions. We will be spending 2 days on this, and this is day 1 of it. Okay, after that we'll be preparing for our unit test, so please be prepared that there's a test coming up shortly on exponential functions. All right, so we have learned already, folks, that the difference between an exponential function and any other parent function is x, the variable, is always going to be part of the exponent. That's why we didn't include it as parent functions in our first unit on Intro to Functions. Second of all, there will always be a value for the base, a numerical value telling us if it's a growth or a decay. So we're going to be using this formula, y equals ab to the x, okay, where y is your future amount or your end value, x is the number of growth or decay periods or your time factor, a is your initial amount, and b is either the decay or growth factor. What you may also realize is in society, folks, instead of giving a factor, it gives a rate. So interest rate is one of those examples. We talk about population rate increase. So sometimes, folks, you have a growth rate. Okay? So in a growth rate, you will find that to find the rate, you take the base and subtract 1. So how far from 1 is that? Okay? As well as, sorry for the, sorry. Sorry. Okay. The opposite could be true is you could have a decay rate. Okay, and your rate is going to be 1 subtract b. Just remember that rates are given in either fractions or percents. Okay, often when you're given a word problem and the rates are given, guys, instead of using b as our base, we actually just replace the base part with 1 plus r for a growth. Or we take the base and we make it 1 minus r for decay. All right, so it's either going to be how much greater than 1 is an increase or a growth, how much less than 1 is a decay or a decreasing function. All right, so we're going to use a bunch of these facets, and it's very important that you try not to get the growth factor and the growth rate mixed up. That's where we tend to find the greatest number of difficulties in dealing with these exponential applications. All right, example 1. The growth of a population of a town is given by P at n, which equals 2,750 times 1.045 all raised to the power n, where n is the number of years since 1994. So if I just underneath of this rewrite our basic exponential function, this is what it looks like. So question A says state the initial population. Well, the initial population is going to be what your A value is. So because normally A equals 1, but if A is a value for your y-intercept, you're going to have, in this case, our y-intercept would be 2,750. So initial population is, so it's 2,750 since A is 2050. All right? Okay, and maybe since it's a word problem, you go therefore initial population is 2,750 people. All right. B, find the growth factor and rate. First of all, looking at the expression, the base is greater than 1, so that tells us we have a growth. Okay, so the factor itself is B. Okay, so that tells us that B equals 1.045. But then we're asked to find the rate. How do we find the rate? Well, the rate equals the base subtract 1. So if you take 1.045 and you subtract 1, that's going to equal 0.045. And quite often we change that to a percent. So that's where we most often see it in society given to us as a percent. So therefore, the growth factor is 1.045, and the growth rate is 4.5%. I apologize, I forgot to put my percent sign on there, so please put that back. Okay, next part, C. What is the population in 2010? Well, we have to revisit the question and see what year N started at. And N started at 1994, and it's now we're trying to find the population for 2010. So to find N, okay, we're going to take 2010 because that's the year we're looking for, subtracting the year that this started, which is 1994. So N equals 16. So to find the population for 16 years, you go P at 16 equals 2,750 times the base, 1.045, all raised to the 16th. Plug that in your calculator just as is, ladies and gentlemen. Don't forget your brackets. You're going to get approximately 5,562 people. There's going to be an argument sometimes for rounding. We're just going to round to the nearest person. We're not going to worry about, a person missing an arm being 0.75, etc. We're just going to keep life simple and just round it to the nearest person. So therefore, in 2010, the population, you can use short form POP with a dot, will be 5,562 people. Good. Now, the hardest one, I think, of this question, ladies and gentlemen, is when will the population be 8,000 people? So when means N equals question mark. But what we need to analyze here is what does the 8,000 represent? The 8,000 represents the future value. So in this case, P at N equals 8,000. So let's plug that into our formula. So instead of P at N, I'm going to go 8,000 equals 2,750 times 1.045, all raised to the N. Okay, we do want to try to solve for N, because that's what it's asking us to do. So we need to find one way to make this expression easier for us. And again, the N is attached to this base, so we can't do anything about it. But this whole expression is multiplied by 2,750, so we're going to do the opposite, which is divide. Okay, so dividing through, we're getting a little closer. We've got 2.91 roughly equals 1.045 to the N. Now what we're going to do is method 1 is going to be trial and error method. Just grab your calculator and you're going to plug values in, okay? Plug values in for N and substitute them in until you get an answer that's close to 2.91, okay? And when you're doing your trial and error method, remember that in your calculator, if you've got a good one with a display, you don't have to type 1.045 in every time. You just hit your, what you call your left arrow button, folks, after you've done one calculation, and you should be able to go in and just change the number without having to type everything out again. All right, so let's start plugging numbers in. Okay, first number that comes close for us is N equals 24. So what does that look like? It's 1.045 raised to the 24th. Okay, so what does that equal? 2.876. And then we'll go one that's another one that's close, where N equals 25. So that's 1.045 to the exponent 25. And that equals 3.01. Then all you need to do, folks, is say which one of these values is closest to 2.91, and that's this one. So this is the closest. Okay, so we are then going to use that it's been 24 years to get to, so N equals 24 means it's 24 years to get to that population of 8,000. But what year did we actually start that formula from? 1994. So you got to go 1994 plus the 24 years it takes to get to there, okay, equals 2018. So therefore, in 2018, the population will hit 8,000 people. Now, I would say method 2, which is probably easier if you have the technology with you, is to use a graphing calculator. Okay, and find what we call the point of intersection. So method 2 is using a graphing calculator. And I'll pull one up and then maybe just pull one up. Hopefully it won't take too long, and then we can put some values in. So what we're going to do is for the first equation, we're going to let it be the left side, which is 2.91. It's going to be a horizontal line. And then for y2, we're going to plug in 1.045 raised to the exponent of n. And see how we do here. I will mention, as this is loading, ladies and gentlemen, that in grade 12 or grade, let me see, yeah, I think grade 12, I know for the MCT4C, I think for the functions, you use what's called logarithms to help solve this. So you will develop in grade 12 a way to solve these accurately using logarithms. Okay, if you look on your calculator, you might see a button that says log, L-O-G. That's what that button's going to help you with in grade 12. But for now, we're going to go to the y equals. I'm just going to clear my equations. It looks like I've got them from last lesson up still. Okay, for my first equation, I'm going to write in 2.91. I'm probably going to have to fix my window here too. And my second one is going to be 1.045 raised to the exponent x. All right, so let me fix my window here and see what we have. Not worried about my minimum. I'm worried about my maximum. Let's make that 50 just to see how we can get there. For my y minimum, I'll do 0. And maximum, let's do 30. Let's just see how this works here. See if it'll graph. Okay, there's my horizontal line. Here comes my exponential. All right. Okay, so we've got that graph, ladies and gentlemen. And I'm just going to use the calculator button to do the point of intersection. So I go second calc, intersect, which is 5. I go first curve, enter, second curve, enter, guess. Okay, and there it gives me x being 24. It tells me 24 years. Let me just go back and see if I can capture that and pull it in here. So grab my camera, I go back, take a snapshot. Hopefully it'll come in on me. Okay, and there it goes. Okay, I'm just going to copy and paste, and just going to cut it and paste it into our lesson. Okay, let's paste it and see if it'll work. There we go, guys. Technology can be wonderful at sometimes when it's working, isn't it, right? So we got the P of I giving us the exact value of 24.27 and 2.91. Okay, so again, you would take that answer of n being 24, add it to the 1994 that we have to get that. All right. Now we're going to go to the next page, but I think I've just added a new page by accident, so let me just clear that out. Okay, and here's our last example for today. Now, this used to be 2 years ago a really hot item, a 64 gigabyte iPad. I don't know if it's obsolete now or not, but it's not going to be as much of a cost as it was when I created this lesson 3 years ago. Anyway, taking a look here, 64 gigabyte iPad costs $849. It depreciates by 24% each year after the purchase, okay? Determine the value after 18 months. Well, first of all, depreciates should tell us, is it a growth or decay? Depreciates means the value is getting less, so it's going to be a decay. Let me take a look at our question. Okay, so when I start with my original formula, y equals a times b all raised to the x, what information do we know? Well, a represents the initial cost, so a equals 849. Okay, my base is something we need to figure out. Just remember, oh, sorry, I don't need the the bracket there. I just need to write B. So B equals, now we have to take a look here. This 24%, which really is 0.24, does that represent the rate or the growth factor? That's actually the rate. So in order to get the base or the factor, you have to say, hey, how far is that off of 1? Okay, so it's going to be 1 subtract that rate, because it's a decay, which is going to be 0.76. And X is our time factor. Remember that it says it depreciates 24% each year, but then it says determine the value after 18 months. Just remember we have to have the same units here. So we're going to make it 18 months over how many months in a year? 12. So that's going to equal 1.5. So again, I'm just going to emphasize here, need to have same units. All right, so let's plug this in, ladies and gentlemen. So what do I know? I know y equals a, which is 849, times my base, which is 0.76, all raised to my exponent 1.5. Plugging that in our calculator, you should get that it's $562.51. There's another method that you could use, which is the formulas we gave at the bottom when the rate is given. Okay, so you could choose to do y equals a 1 minus r to the x. In this case, you're using the information given, so you would write down y equals 849 times 1 subtract 0.24. That's what we did in the margin work anyway, divided by 18 over 12. And again, simplify that exponent to 1.5 or plug it in as is, that's fine. You're still going to get $562.51. So therefore, in 18 months, the iPad, will be valued at $562.51. All right, class, here ends our first day of applications 4.7a. Your homework today is page 261, numbers 2 to 5, 12, 13, and 15 and 16 are challenge ones. Give them a try. And as always, come see me if you need extra help, and have a great day.